All right. Welcome back. This is now week 2 of the CAD training course. Hopefully, you guys all turned your assignments in, as we just do a couple minutes ago. So having a week now done, we all know how this course runs, and so today we're going to be covering module 2, which is about most of the meat of the class. We're going to be doing a lot of things pretty quickly because we're going to try to cover a lot of the good tools hidden inside Fusion. So we're going to start off with talking about constraints. It's a really good tool for Fusion and CAD in general. And then we only have 2 assignments that we're going to do. So in total, this class should not go long. I know we're always blocked for 2 hours. The first 2 weeks, we always finish early on time. The third week always runs super late. And then the latter ones also end pretty early. So hopefully we'll have you guys out of here quicker than the 2 hours. And then of course, if you want to stay and work on your assignments, we're always here to help you out. But if not, I know many of you probably have exams tapped into this week. I know we all do, so thank you for coming. And then you guys are obviously free to go. Before we begin, does anybody have any questions about what we covered last week, how they submitted their files, anything in general? Okay, sweet. So like last time, I sent out all the material in our Slack channel under course material. So in there again, you're going to find the weekly attendance. So please fill it out. It's how I make sure that you're coming to class and you're progressing through it. You're also going to find the submission link for all of the assignments and the rubric for everything. Again, there's no surprises in this class. We tell you exactly what is expected from you. So no surprises when you're turning stuff in. And then additionally, we're going to be doing an exercise at the beginning of the course. So there's a link there to get that done. So the first thing we're going to talk about is constraints. So whenever we were talking last week, right, we were making all these shapes and we were applying dimensional constraints to them, correct? Right? We would go to the dimension tool and we would give all of our lines, our diameters, all of our points, right? We would give dimensions, right? You are 2 inches in length, you are 1.5 inches in height, radius of 1.5, right? So you have to constrain your sketches. You can't just have arbitrary values for everything because then how do you design anything, right? If you look up here, I don't know if any of you saw these when you walked in, but these are the final projects from our last semester. We'll have students coming in during the session. I hope it doesn't get too big of an interruption. But as you can see, whenever you start to put multiple shapes together to make big products, you can't just have loose arbitrary numbers, and you have to have some sort of constraint, right, to tie things together. And there's 2 ways you can do it. The first one is dimensional, right? That we covered last class. Straightforward. You click a button and you assign a numerical value to all of the properties and shapes that you see on your screen. The second one is geometrical constraints. So this is a chart. I would recommend opening up the slides. Again, a copy of this is in the slides, so a little bit easier to look at if you have it in front of you. But what is going on, right? So 2 types of constraints. The first one is dimensional. That is numbers. And then there are geometrical constraints. So if any of you have ever taken a high school geometry class, you already understand everything that is on the screen, right? This is nothing groundbreaking, super straightforward information. Concentric, 2 circles share the same middle point. Collinear, 2 lines share the same vector. Parallel, perpendicular, midpoint. All right, there's some more on this next screen. Tangent, equal, symmetry, horizontal, vertical. And so how these come into play, I'm going to open up Fusion, is you generally have 2 options when you're designing your parts. You can either add a number to it, or you can add a constraint to it, right? Constraints are laws. You and you must be perpendicular. I want these 2 lines to be equal. And you can run a combination of them as you start to build up bigger models. Sometimes one is going to be preferred over the other, right, in certain instances, but you generally want to use them together as you start progressing through your part. So just to show you where these are, and again, we're going to be doing a little demo just to get you to understand what they are. This is something that kind of gets put into the forefront of CADing. It's not like a finish where it's the last thing you do, but it's generally something that you do first. And every time you start a new sketch or a new line, you always take into consider constraints. So we're going to start up a new sketch. And automatically you're going to see constraints, right? On the top right-hand side, you're going to see all these red shapes. And these are constraints, right? So these allow us to apply geometrical properties to shapes on our screen to kind of give better form to what we are CADing. So, for example, I'm going to make 2 circles. And from here, right, like I said, the slides are available if you want to go through and read what they are. This is basic geometry terms. So I could do concentric. I click on one circle, I click on the other, they now share the same midpoint. And I can drag in, and you can see just like that. You can do other things with lines. So I'm going to put 2 lines on the screen. I can make these 2 perpendicular. So I'll add a perpendicular constraint, and these 2 become now perpendicular. You can make them equal in length, right? So these are laws that you can apply to your CAD model to make it a lot more rigid, and that way you don't have to be assigning all of these numbers, right? One constraint sometimes will do the work of 3 or 4 dimensions, and it really makes your CAD models really fluid, and understanding it is a good essential to becoming a good, efficient CADer. So again, this is one of those things that's best done just through practice. So if you open up our Slack, we're going to take a little bit of time to do a demo. So in here at the bottom, we have this thing called a constraint activity. You can open it up. This is a website that my high school engineering teacher showed us. I love it. The link's going to be there. So if any of you want to go through and mess around with it, it is there. So every day is a different lesson on a different CAD tool. And the one we're going to be going to is about, I think, 27. So you're going to go and push download activity link. Download it. And then we're going to go open up Fusion. This is also a great time to show you how to import stuff into Fusion. So whenever we get to our final project, right, some of you may want to import parts into Fusion to tweak around with. So I'd pay attention to this, as this is really helpful. So we're going to start off a new sketch, and we're going to go over to the top left-hand side, which is our File button, and we're going to open it up, and we're just simply going to go over to Upload. Right? So you're going to get this screen, and you have 2 prompts. You want to tell it where to save the file and what file you are importing from the internet, right? So this thing that we're importing is a interactive worksheet that this person made, right? It's free, and it does a really good job of showing you what constraints are. So we're going to go to Select Files, and then under Downloads, right, we're going to find it, and we are going to import this into Fusion. Sweet. So you'll see, right, it's just a simple sketch with some instructions, right? It's just like a follow the step book. And what we're going to do is on the bottom left-hand side, right, this is our tree. This tells us the path that we've taken to make our model. So if you go to the only sketch there and double-click it, you can now edit what you have in front of you. And like I said, constraints is honestly one of the top 3 most important things to understand about CADing. It will absolutely make your model so much better, efficient. You can make them faster. And like I said, it's just basic knowledge of geometry. You just need to understand, right, these buttons are on the top right-hand side, and play around with them a little bit just to make sure that you fully understand what they do, right? You select one of the constraints, and again, you can hover over your mouse. It gives you a little bit of a description in case you're not too sure what it is, and then you can just run through the worksheet, right, practice all the constraints. It'll highlight the most important ones, and you can just familiarize yourself with some of the language of this program. So we're going to give about maybe 5-10 minutes. We're not taking this for a grade, but I would highly, highly recommend that you do this, right? This is a really good, essential part of Fusion and CAD in general. And again, if you can't get it open, just call any of us over, but it is that link we attached. It's day 27. If any of you are looking for extra CAD practice, right, this is something that somebody made over quarantine. So each day goes over an in-depth tool for Fusion. It covers way more than we do in class because we only have about 10 hours, and this whole program probably takes a lot more than that. But it's a really cool resource. We've always been asked, what more can I do? Obviously, the first recommendation was just to practice, right? Something that every CAD professor is going to tell you is just to model random things in front of you. But if you want a little bit more structure, right, a course like this will kind of give you some more guidance. There's YouTube videos attached as well. And like I said, we're just going to give you a little bit of time to run through this. Also, I will say, the last thing I'll say, if you want to come up and just take a look at this again, just to get you some ideas or what to look for towards the end of the course, all up here are some of the final projects from last semester. So if you want to stand up and come take a look, you're more than welcome to. In the link attached. So it's in the link, right? They open up the website. It's a program. Day 27 has a download link. There's the importing of Fusion. So to round off the minute, I just want to show you a little bit of a demo of like why and when you would want to use this, right? So constraints, we have to apply values to the designs that we make. You can do dimensional, which is this button up here, right? That's whenever we are adding numbers to everything. Or you can do geometrical, which applies relationships, right? So it's values versus relationships. So I made this sketch. I did a horizontal line with length 4, and I did a vertical line with length 2, right? So this is a way of making two perpendicular intersecting like at the midpoint lines, right? You can see that this vertical line is at the midpoint of this long one. And I have these two created by dimensions. So if I want to go in and change my sketch, right? Let's say I go in and change this to 5, right? It's no longer at the midpoint. They were only at the midpoint because they were held by the values, but as soon as you go in and change those values, those get deleted and erased. So what you could do instead, and this is the power where constraints comes into hand, is we can add a constraint to it instead, right? So midpoint, we can make this line midpoint to that. And then now, since there's a relationship instead of a numerical value applied, as I shrink and grow, and I can even slide this line around, it's locked there, right? So it has that relationship held to it. And then likewise, like here's a triangle, right? It's 2 by 2. And let's say I want to make this, so that this leg and this leg are the same. And I realize this is small, I want to make it 3 by 3. It would take too long to go 3, 3 than it would if I just deleted these values and I went equal. I made these two equal, and then now as I apply a value to the bottom one, or as I apply a value to the top one, the bottom one changes, right? So it's just a different perspective to do the things that we've been doing. Instead of applying numbers, you're applying relationships between different features of the sketch so that as you go back and start to change things, right, everything is modular. It adjusts together. Okay. So that was just an activity. Again, all this thing is learned through practice. We're just kind of here to introduce it to you, and you learn this thing by practicing it yourself. So you don't have to turn this in. I just hope you were able to kind of familiarize yourself with this concept. So we're going to go into our first assignment, and we're going to try to utilize some of the things that we've already gone ahead and learned. So we're going to be making a gear. And so we're going to be making a center wheel, as you see on the left sketch. So a center wheel with all of the spokes around the side, and then we're going to be adding a thread to it. Again, the rubric that we submit is way more detailed than this. These slides are a little bit more vague, but I'm going to show you guys how I would do this using some pattern tools, right? So that's the main goal of this assignment, is to show you patterns. The best way to CAD is to be efficiently lazy. Make the software do as much for you as it can. Make it do copies for you and algorithms, and you want to try to do the littlest amount of work and then let the processing power and the power of the software in general do all of the complicated heavy lifting for you. So you'll see just how very little steps we'll take to make this shape, and then we'll let Fusion do all the work for us. So again, I'm just going to go through this quickly. We'll give you guys some time afterwards to do this yourself. So I'm going to start off with a sketch. And I'm first off going to make a center for my gear, and I'll dimension it to 5. So tandem, I think what works best together, right, this is what I found out, you want to use a combination of constraints and construction lines to sketch out your body, and use dimensions only when you have to, right? I think that's my general rule of thumb. You can ask other people, they'll say otherwise, but that's what I like to do. Try to use as many constraints and construction lines to make your more complicated parts, and then as soon as you have to, then add dimensions. So I'm going to start off with the construction line, going from my center all the way up. I'm not going to assign a value to it because it does not matter. And then I'm going to make another line that is horizontal, and I'm going to make this one a midpoint of that one. And likewise, we're going to go tangent to the circle. So now we have, two lines that are going to kind of be the reference of where we're going to be making one of the gear teeth. So I'm going to start off with another line. I'm going to switch off construction, and I'm going to go up to my top. I'm going to pull out, and then we're going to go down to the bottom, just like that. And then from here, there's really not too much I can do, so now I'm going to begin to start applying some dimensions. So for this, we'll do 0.5 And again, these are all arbitrary. You can pull out what you like. Instead, we'll take an angle. So we'll take an angle between these two. We'll do 110. Let's see. You can always move your sketch around if you want to figure out what is not dimensioned. So now I'll give this a height. We'll say this is 1.5. And we have this, right? So this is not a closed body. We need to do a couple more steps to get it closed. The first thing, right, so last time we covered the trim tool, which is under modify. Modify is really quick fixes, whereas you could manually go in and, delete the line or extend it, right? There's little quick buttons here to do it for you. So we're going to use the extend tool, and we are going to extend this line so that it touches the bottom. And this is about 75% of the work that we're going to do. The rest we're going to let Fusion do for us. So next, we're going to go over to the mirror tool. I'm not too sure if we covered this last time in class, but this is another great example of letting Fusion do all the work for you. We're going to go to mirror. We get 2 prompts. Select what you want to mirror and where you want to mirror it about. So we're going to select these 2 lines, mirror line. We're going to select this vertical line. We want to copy it across this. We're going to push OK. And everything is driven. So if I'm unhappy with the sketch and I want to go in and change it, I can make this 1.2 and everything changes alongside with it. So maybe just to make it look a little prettier, I'll shrink that down and maybe change the angle a little bit. Okay, so that took us a couple minutes to make one, and we want to add maybe 8, 9 teeth to the gear. Instead of doing that manually, again, we're going to let Fusion do it for us. So under Create, we're going to go to Circular Pattern, and as we always do, we just read the prompt and follow the steps. What do we want to make a pattern of, and where are we going to make it around? So we're going to select the 4 lines that we have, center point, which is the middle, and then we get some more options. So I want to change my quantity up a little bit. We'll keep making more, and we will stop at 7. We'll go to Finish Sketch and Extrude, and now what we've done before in the past is Fusion's going to automatically select the body for us. But you'll notice we have 8 closed bodies. Each of the teeth, there's 7 of them, and there's the middle. So we could go in and click all of these, but it would take forever, or we could just go off to the side, drag, and it selects them all for us. We'll apply a value, so we'll say 1 inch, and then we're going to go and add a hole to this. So what I want to say is it seems a little redundant, and it's going to be taught by most CAD teachers, and you don't really understand it until you go into manufacturing. Whenever you go to add holes to your parts, never create a sketch, right? Create a circle and then cut it out. It's just bad. And I'll explain why. So currently in engineering, there's a technology called CNC, which is computer numerical control, which allows you to send parts that you make on Fusion or CAD in general to automated machines, and they will cut them out for you. If you go under Design, there's actually a Manufacturing tab, and you'll see your headliner changes, right? There's lots of drill features and cutting features. So Fusion is the best at this, in my opinion, right? Each of these CAD softwares have their own specialties. If you need to go and change back, you go to Manufacture and Design. And again, this is how you tab in and out of them. Fusion does this really, really well. And right, so you can design these complex parts and you can send them out to a machine to get them made for you, right? The coding that you do on here, so under the manufacturing tool, you're going to be writing code to tell the computer what and how to cut the parts. The reason you do not want to just make a hole and cut it out of any of your parts is you lose a lot of the data hidden inside the instruction. So whenever the machine goes to cut that out, it doesn't really know what's going on. There is a whole tool called the hole tool, right, that is going to be used to make all of your holes. This holds a lot of data for the machine, and whenever you go to CNC your parts, right, the computer's going to be able to do it properly. It works very similarly to what you would do with just making a sketch and making a hole. It's just a little bit weirder. There's its own separate feature, but that's why it exists, and that's why you're always going to be told to never, ever just create a circle sketch and extrude it. You want to use the hole tool, as it just holds so much more data for the code that will be sent out to machines to manufacture these parts. Again, we don't have to really worry about it. This is an intro to CAD class, but you always want to have a bigger understanding of stuff, because if you begin to grow and any of you become machinists, This is something that's going to be required of you to know. So we're going to go to the whole tool, and all this does is you select a point where you want the whole center to be. So I want the whole center to be on the middle, and then we get, as you see, tons and tons of data on the side of my screen. We have what type of hole type do you want? So just a simple straight cut. Maybe you want a counterbore or a countersunk. Again, all manufacturing terms you may not need to know, but all we're looking for is a simple hole type. And then down here, again, is all the values that you need. So this bottom one is the most important one, which is the diameter. So for this, we'll keep it at 3. And we now have a hole inside of our gear. The last thing we're going to do is we're going to add a thread to it. So in order for you to create a thread, you need to already have a hole, right? This feature needs to be nested in a pre-existing hole. If I create the thread tool, you'll notice I can't really click anywhere on the screen and create a thread. The only place it lets me create it is inside the already existing hole. So we're going to do that. Again, these are all just manufacturing specs. If you go to a website like McMasterCard, you can buy certain threads for whatever parts you're making. For this, does not matter. You can grab literally any of them. And this is what we're looking for this assignment, right? We want you to try to make this using as little work as possible. Use the mirror tool, use the circular pattern tool, and then use the hole wizard tool. That will be graded for. So down here, the reason we ask you to screenshot your whole screen is because we want to see that you're using the right steps. And if we don't see the hole wizard tool, you're likely going to be penalized for that because we know that you did it the wrong way. I know it's kind of a stickler thing, but again, it's just one of the better practices to do. If you learn it now, you won't have to worry about it later. So we'll give you guys like 5-10 minutes to work this through. Again, if you need any help, the slides are there, we're here, and you have the rubric to know exactly what is expected from you. Circles, it does dimensions, lines, it does radial. If you click 2 angles, it just knows. Okay. So it's all built into this. How many of the page are you I got 2 personally sent to me. I graded so 44 out of 53. That's not too bad. I mean, yeah, this is to expect. A, there's a lot of midterms this week. B, since this class, right, the spring semester always has less enrollment for us because, right, it is a beginner CAD course. So the only people that are going to take it are people who want to learn CAD. If people want to learn CAD, they're going to do it first semester. So there's going to be less people in the second semester. Most of these people, I think, already know CAD just based off of our survey data. So if they realized in the first session one, I wouldn't put it past them to not come. I mean, I would have been egotistical about it and not showing up. So we'll leave it open for maybe a little bit more. Hello? Okay, sorry. We always get asked this every time I do this, so I want to address this question before somebody comes up and asks. Um, so like I said, every CAD program has its pros and cons. Fusion is really, really revolutionary. I think it does a great job of being good at everything, right? This button up here pretty much reveals the power behind Fusion. You have the ability to render stuff, you can animate stuff. The manufacturing tool is really, really powerful. I know one of my friends in Baja, they CAD in SolidWorks, which is one of the higher end programs, but then they import their parts into Fusion and they do all the manufacturing coding in here, right? So Fusion excels at a lot of things, but it does a poor job at some. In my opinion, what it does really poorly is deleting constraints. For like example, SolidWorks, there's a big, nice pop-up screen on the side. So if any of you want to go and delete constraints or mirror tools or um, patterns, you'll notice all of these have icons, correct? Right. So the circular pattern is the circle tool. The mirror tool is the two triangles. All of these constraints have their own icons. So if you want to delete any of these, right, the best way would be to Control Z. But if you're too far into your sketch, what you do to delete these is you have to go in and find the icon, click on it, and delete. So if I wanted to delete the pattern tool, right, it's safe at the center. I go and find it, and I delete it. And then it gets rid of that pattern tool. So these are actually no longer driven, and I can go ahead and delete these. And then likewise, if I want to delete a perpendicular constraint, you go and find that icon on the screen. It's going to be right next to where it is being applied, and you just click on it and delete it. one of us created it and didn't realize it. So if you're correct.
Above that, it's through graded before that.
It might have just been a copy. No, okay, I just created hers before. Hers is 10, 10, 10, 20. Okay, honestly, it might have been me. So you can add the 20 and then remove from the other girl. Or remove from the guy. Okay, so we're going to move on to the next assignment. I know some of you are not done, but we have very little left to cover. We've only been here for 30, 40 minutes. So I'm going to try to go through this assignment. This is the last thing we have to cover today. And then, we're going to let you guys stay if you want to work, or leave if you got to go. So what this assignment is if you look at the rubric, we're making a hairdryer. And it's a rather complex shape, right? I'll quickly burn through the slides. You can take a look. But our whole goal of it, right, is again to try to do as little work as possible and utilize the power of Fusion and CAD to do most of the heavy lifting for us. So we'll break this up into sections. I'll do the first half, give you guys some time. I'll do the second half, and then give you guys some time to follow up. So looking at this slide, let me open this back up. We're going to be making the head of the hairdryer first. And you'll notice this is a very odd shape, right? It is symmetrical, so what we could do is we could do a side profile and do a revolve tool, right? We used the revolve tool last time in a week to make the game piece. So we could do that, right? It's a pretty unnatural shape, so trying to use circles, lines, and squares would be pretty difficult to do that. Like I said, we could do a revolve tool that would work, but we're going to try to take a different approach and see where we can get from there. So I'm going to open up a new file in Fusion. And first thing I'm going to do is I'm going to turn on the origin, right? So whenever you go into Sketch, Sketch is always going to turn on the origin for you. By default, it's always turned off because it gets a little bit annoying. But for this, we're going to go ahead and turn the eye icon on so that we can use and reference it throughout this exercise. 3, 4. Okay, so as we covered last time in class, right? Whenever you create a sketch, you have to create a sketch on a face or a plane. By default, you have 3 planes here, X, Y, Y, Z, ZX. And anytime you make a shape, you get more faces. What if you don't want to make a shape and instead you just want to make more planes? All the way over here on Construct is a whole drop-down menu of new ways to make new planes. Personally, I have used Fusion for almost 5 years. I do not think I have used a single one below my cursor here. They're pretty complicated to use, but the first 4 you're going to be using a lot. So you have offset plane, which allows you to make copies of faces and kind of push them out a little bit. We're about to use it, so we'll show you what it does. You can do plane at an angle. So if you want to have a plane at 45 degrees, or you want to make a plane tangent to a circle face, there's also a mid plane. So what we're going to go ahead and do is we're going to go do construct and offset plane. So we're going to click on a pre-existing plane and we're going to add an offset to it, right? An offset is a height or length between them. So we're going to click on our bottom plane and we're going to add an offset of, let's say, 2.5 inches. Push OK. So now we have this bottom plane down here, we have this top one up here, and we're going to keep on going, and we're going to be creating a few more. So we'll go to the bottom. This time we'll make one of 5. So we now have 3 of them. Click and drag them out, make them a little bit bigger and easier to see. That might be a little too big. Right, so we have this plane, this plane, this plane. We'll get one more just for good measure. So we'll go to the bottom. We'll make this one 8. So you can now see we have 3 planes. Turn the origin back on, we have the bottom 4th one. So we're going to use this to make different levels of our hair dryer, and we're going to use the loft tool. So just kind of follow along with what's going on. I'll explain kind of the logic and what's going on inside of Fusion. So we're going to make different profiles and sketches of this hair dryer, right? As you can see on this picture, there's 4 different circles. So we're going to be making little cuts, little views of what we see, and then we'll be connecting it all together. So we'll start off with our bottom plane, and we'll be making a circle down here. This is going to be our base of the hair dryer. So we'll say 6 inches. Finish sketch, and then we're going to go on to the next one. We'll also go to the origin. For this one, we'll make it a little bit wider. So we'll go to 8.5. And then we're going to do the same thing. We'll go to the third one. We'll make this one a little bit thinner than the second, but still wider than the first. So we'll go 7. And then we will finish sketch. We will add one more circle to the top. And this one will be the smallest of them all. This one will make 5.5. Okay, so now we have kind of this line of saucers kind of stacked up on top of each other. These are little sections of the hairdryer, and these are called profiles, right? We're going to be using the Off tool, which is under Create, right? The most common tools are on your taskbar. The more niche ones that you don't use as common are hidden underneath the Create button. And we're going to go to Loft. What we're going to do, right, what this tool does is it grabs multiple profiles and it kind of computes the rails or the paths between them and then makes a solid shape based off of the distances between the paths and the size of the profiles that you have. So we'll go to Loft, and again, you just follow the prompts on your screen. Profiles. So what are we exactly making copies of? What are like the dimensions of this 3D shape? So we'll select our 4 circles, and it's automatically going to do the rails for us. And as you can see, it turned out a little odd. But what we're going to do is we're going to go in, and we're going to change it a little bit. So we'll go to the first plane. We'll make it a little bit bigger. So we'll up it 3, and then we'll go to the next one. We'll make this one 6, and then we'll make this one 10. So it starts to elongate a little more. I'm going to try to make it a little bit skinnier. So again, the bottom left-hand side, this assignment is the first one that really requires a lot of editing. The numbers, as you can see, I got them wrong. So you can go into the bottom and start tweaking with the numbers a little bit. I want to make this a little bit skinnier. So we'll go to 4.5, finish sketch. And you can see we're slowly getting there. I'm going to change this one down to 6. And I think I'm going to add one more change to it. We'll make this 6.5. And I think I'm good with that. We'll make this one 12. There we go. So we now have the head of our hairdryer. As you can see, we could have just gotten this profile and revolved it around, but it would have been a little complicated as these are kind of unknown arcs. So we're able to take these little profiles, right, these little sections of, I'll enable these as you can see them. We'll take these little sections of parts of the hairdryer and then we'll connect them all through the railing system. So the Loft tool is really good. If you want to make some pretty unnatural features, it's a good way to create them since you don't have to use the Revolve tool or kind of manually CAD them all in. You can just kind of give some parameters, tweak them a little bit until eventually you get to this shape right here. So next, what we're going to do is we're going to go and add a fillet and a shell. So we'll go back to our body, and we're going to use the shell tool to make this hollow. So again, we're going to go under Modify, we're going to go to Shell, and we're going to select the top face of the hairdryer. Do not select the outside, right? You want to select the shell. Look at it kind of like a vase. The way that I like to describe the shell tool is you want to select the opening to the vase or the cup, right? Don't select the actual walls of the cup, but the entrance to it. And then it's going to go in and take all the matter from the inside. It's going to hollow it out. So we'll add a thickness of 1/8. That's what we want left, and it'll cut out everything inside. As you can see, it is completely hollowed out. And then we're going to add just a quick fillet to the edge. We'll make this one 1/8 as well. And then we now have the head of our hairdryer. All right, so next we're going to add the handle, and then we will stop here to give you guys some time to catch up. So we are going to go back to Fusion, and we're going to make another offset plane. And what we want to do is we want to offset from one of these side planes. So if I zoom in, I can kind of click the corner right here. If any of you struggle to select the planes, right, often when you get really big, complicated parts, things are going to get in your way. So if you want to go in, you can always turn stuff off to give you more room to navigate around Fusion. So you can turn the body off if you want to click on it. Sometimes you'll get lucky and it'll let you click on it. So we're going to select one of these side planes. And then we're going to pull out until we get tangent to this line right here. I did forget, so I'm going to go and find what this value is. So this is 8.5. So we're going to go in, and we're going to add this value to be 8.5 divided by 2. So if you didn't know by now, you can actually type in simple algebraic functions into Fusion. So plus, minus, division, subtract. And it's a lot more simpler than having to go and use a calculator offhand and plug in the numbers in here. So in this case, instead of having to calculate 4.25 myself, I can let Fusion do it for me, and we now have this plane right here. We're going to create our sketch, and I'm going to create the handle in the middle of the hairdryer. So I'm going to go, and I'm going to snap on to the bottom of this line, right? So if I wanted to put this in the middle, sometimes it'll let you snap on. As you can see, as I move my cursor across, it snaps on to the line. If you are not able to get that feature, right, if you ever want to put a line in the middle of something, you always have to go to the midpoint. It'll snap on, it'll realize what you're trying to do, and then now I can go ahead and I can create the handle for the hairdryer. We'll give it a dimension. We will say 5. We'll go to finish sketch. So if I go to my side profile, you'll notice there's these little pockets of air above and below. So if I go to extrude, and I'm going to extrude it, you'll notice that it's not fully in contact with the body, right? Again, there's these little pockets. Extrude only lets us extrude it one way, but we need to make it go both. So how could we do that? Underneath extrude, right, there's a whole nother menu of options. If you go to direction, we can change it to 2 sides, and then now we can have it extrude inside of the hairdryer. And that way we eliminate that little pocket that we see right here. And then whenever we push OK, again, it's one big conjoined body. We no longer have that pocket to deal with. Okay, so that's about half of the assignment. I went slower, and it looks like most of you are following along, but for those of you who have not, again, we're going to give some time to run through it. We're making a pretty complicated shape, so we're trying to let Fusion do most of the work for us. We use the loft to make the complicated head shape of the hairdryer, and then we're doing some planes so that we can start creating these bodies where we want them to be instead of using the default X, Y, Z. going. So we have like 10, 15 minutes left where thanks to show. We're gonna end pretty early, and then of course, if you guys want to go, you can. So I want to show you a few things, some flaws about this design, and just how we can fix it. So I'm not too sure if you noticed, but if you look inside of our hairdryer, let me see if I can actually cut into it. So we cut into our hairdryer, you'll notice that we have this little part sticking out, right? Which really shouldn't be there. It's not how this design is meant to be. So down here, as we mentioned before, is our timeline. If I haven't mentioned this already, you can push play, and it shows you a live action of what you've been doing to make your part. I think that's pretty cool. But it also shows you the chronological order in which you've made things. And you can actually rearrange some things, which is really, really cool. So to make this a little bit better, what we're going to do is we're going to go to our shell. We're going to click on that, and we're going to drag it all the way to the end. And you'll notice I'll do another analysis, sectional analysis. You'll notice that that stick out is now gone. So we redid the order of the steps, and the result that we got was completely different. We made the handle first, right? So you can also grab this cursor and move it back. So if you want to suppress some features, I'll move it back once. You'll notice that what we did was we made the handle first, and then we added the shell. So it removed, in that shell tool, it removed the part that was sticking into the body. So if you find any defects, you can always go into the bottom timeline and you can rearrange the order in which you do stuff, and your outcome will be totally different. And this is just an example of you being able to do that. So really quickly, I'm gonna go ahead and chamfer this bottom part of the handle. I don't think we've covered chamfering in this class, but chamfering is pretty similar to fillet, whereas fillet rounds off your corners. Chamfer kind of cuts them off at a taper. So we'll add 0.25, there you go. And you'll see instead of doing a fillet, we're just getting a nice slice across. You'll notice it's a line. Instead of a rounded corner, it's a straight cut between the 2 points that we selected. So now the last thing we're gonna do is we're gonna add a cable to this hairdryer, which is pretty weird because we've been dealing with pretty inorganic shapes today, and this seems to be the oddest one that we've touched so far. So I'm gonna pan over to this right here. This is a sketch of a coat hanger. So the way coat hangers are made, right, if you think about the really old ones made out of wire, right, it's just simple wire that's curled and pressed in certain ways to make this shape. So if you want to make something like that, right, anything wire shaped, there has to be a better way than doing basic extrusions. And there is. It's called the, right down here, you'll see it's the sweep tool. And it works pretty similar to loft. You'll notice they're right next to each other. Whereas loft, you kind of make the profiles and Fusion kind of artificially connects them. For sweep, you get a little bit more in depth to it. So you make a profile, right? And then you give it a path to follow around, right? So if I wanted to make a coat hanger, and this is a very basic example that's always taught in a CAD class, what I'm gonna do first is I'm gonna make, right, the coat hanger profile, and then I'm gonna go ahead and make a little cross section of what that looks like. So you'll notice right up here, I have this little circle up here, which is the thickness of that wire. If I then go to the sweep tool, I can make, right, because this is a sketch, it's infinitely thin, I can make infinite copies of this infinitely thin sketch and give this whole profile, or this whole body, some actual 3D. And you'll see just like that, right? So this is just a demo to show you what it does, but if you want to make these more curvy shapes that follow a path, right, this is what we're going to use. It's the sweep tool. You make your profile, and then you're able to make copies of it along the path. So we're going to go back to our hairdryer, and that's exactly what we're going to be doing here. We're going to create a sketch, and we're going to create our sketch on the middle, right here, the middle of our hairdryer, right? And we're going to go over, and we're going to start to create the cord of the hairdryer. So I'm going to go to line, and I want to connect to this line right here, and you'll notice my cursor is not letting me snap on no matter how far I zoom in, right? So to explain this, all of these bodies and sketches, right, they have the properties to them, right? They have the lines, they have the actual dimensions of the bodies, right? So you can see that there are boundaries to all of these, right? If I highlight my cursor, this line is able to get clicked. There's a line up here, and these were made in previous sketches. So if you make a new sketch and you want to go back in time and reference something that you've already made, right, that's the point. All of these are reference points. You theoretically should be able to use things that you did in the past to kind of progress what you're doing right now. So if you want to reference anything you've done in the past, you have to tell Fusion. Automatically, it's going to lock it out of your sketch, and you have to tell it to import all that data, all the lines, all the dimensions, so that you can use it in a different sketch, right? I made a new sketch. I'm on this plane, so I'm no longer in the old sketch where I made this handle or the head. So what I'm going to do is under Create, all the way down at the bottom is Project. And that basically allows me to get things that I've done in the past, bring it forward to the present, and use it in my current state. So I'm going to go to Project, and I'm going to select this outline of the circle. And the notation for this is purple. Let me see if I can make the body go away. It's purple, right? So anything that you import from the past sketches, past anything that you've done, if you want to bring it into a present sketch or anything to reference, you have to tell Fusion it's this project tool under create, and it's always going to be notated by this purple line. So now I'm going to turn the body back on, and you notice whenever I go to create my line, I now can snap onto it, right? Fusion's allowing me to reference that geometry. So I'm going to make a little bit of a curve. I'm going to make a cable for this hairdryer. So we'll do a sequence of lines alongside with some arcs. So we'll use the 3-point arc, and we'll make an arc like that, and we'll make another one just like this. Oops. We'll make another arc. We'll do a straight part, and then we'll do one more arc at the end. Right, so this is going to be my pretty random cable, right? It's not going to be straight. It's a little bit boring. We're going to try to add some more personality to it. We'll add some curves to it. So now we have a path, right? This is what we want the cable to be, but again, this is just a 2D sketch. There is no thickness to it. So we're going to add another sketch. We're going to combine them two together, and then we're going to get a 3D cable that has a lot more properties to it. So we're going to create a sketch. We'll start on our bottom face, and we are going to create the profile of this sweep. So we will give this an inch, finish sketch. And we have two parts, right? They are perpendicular, they are orthogonal to each other. We have the path in which this profile is going to take, and then we have the profile attached all the way at the end. So under create, we have sweep. We will select the profile. We will select the path. And now we have a cable to our hairdryer. That is the final part for this assignment. I do not believe I'm forgetting anything, but if I do, I will go ahead and let you know. So those are the two assignments for today, right? So what we mainly tried to cover today was using and utilizing Fusion to our advantage, not trying to hard design everything, but letting it kind of help us do that for us. So we did the two assignments that covered a lot of those tools, and then this homework assignment is an 80-20 drawing. So this is a very common metal beam that you will use in engineering. And so our goal for this is just to make a sketch, right? Just to make a sketch and take a screenshot of the sketch. And our goal is to really hit home the concept of constraints. You can read the description here, but we want you to use minimal dimensions, but instead to use constraints to tie everything together to make the fully dimensioned sketch. It should be fully black. Again, all the instructions are here on the side. And it is 6:46. I believe we are done for today. So again, if you guys would like to go, you are more than welcome to. But of course, you can stick around. We are here to help you guys finish up these assignments.